We're going to be doing not all, but a couple of the prerequisites for chapter 1, section 1 in our college algebra class. So notice how I call it 1.1a. So the section number itself is what relies to the college algebra section that we're going to cover. But if you see like an A, B, or C behind it, it's like the prerequisite knowledge that we need. So real quickly, we're going to go through order of operations. Does anybody remember the silly acronym for order of operations? Starts with a P. Please excuse my dear Aunt Sally. Have you heard that before? PEMDAS. So I already heard Shia saying parentheses. So the first chunk is parentheses, or any kind of grouping. Okay? So what does that mean? Well, obviously the parentheses are the most common, but sometimes when you get multiple steps going, they don't use parentheses. They'll use brackets, squiggly brackets, square roots, a big division bar, and then does anybody know what the two vertical bars are with a number in between? What that is? Absolute value. Do you guys remember what absolute value is? It's always positive. It's your distance from zero, right? So whatever's in there, it's a distance, so it's always positive. So all of those are things that we're going to attack first. So like if you see an absolute value symbol, that's kind of like a parenthesis, right? So then please excuse, the E stands for? You're right, so what's the E stand for? What do we need to approach after our parentheses? You got it. So what does exponents mean? It's this little guy, right? So when we raise it to a certain power, whether that be squared, cubed, or whatever it may be. After that, so we have my, right? My dear. M stands for multiplication, D stands for division, but they're actually tied. So this is multiplication / division. And so since they're tied, you move left to right. So what does that mean? It means if you see both multiplication and division in your thing, you don't have to necessarily do multiplication first because it comes first in, please excuse my dear Aunt Sally. You do whatever operations first in the order, right? So if you see division first and then multiplication, that's the order, like how we read is how the order we're going to do those. Same with A and S, those stand for what? Addition and subtraction, you got it. And those are tied as well. So we're going to move from left to right. So again, if it's all addition and subtraction, you don't go do all the additions first and then the subtractions. You just go from left to right as you read, all right? So if you need to, you guys see PEMDAS, please excuse my dear Aunt Sally, right? So here's PEMDAS, PEMDAS. What's nice about this class is if you were taking a Math 111 course, you're not allowed to use calculators, so you would have to know order of operations. For this class, you're allowed to use a calculator, and most calculators do it in the correct order. The key things you're going to want to pay attention to are some of these grouping methods. You're going to want to know to do whatever's in the square root first, because sometimes if you don't enter it in your calculator correctly, it won't do very well. And division, always do the top and the bottom separately, and the division at the very end. So looking at this first one, let's do it by hand, but then I'll show you how we can do it on our calculator. So what are we going to take care of first? The parentheses, right? And what that means is go to the parentheses and do the math inside. What is 7 minus 4? 3. Everything else stays the same. 3 times 12 minus, but then we have 3 cubed divided by 9. Is that okay? So I wrote everything else exactly the same, but I rewrote the one mathematical thing I did. What's the next thing we're going to do? Exponent. So we're going to do 3 cubed. Do you know what it means to raise something to the third power?
Multiply by 3 times.
Yeah, and it only happens to be 3 times because the base, right? The number is 3, and then your exponent tells you how many times you're going to multiply that number, right? And so that gets kind of tricky because like even with 2 squared, it's like, Well, it's 2 times because the power is 2. So what is 3 times 3?
9.
And then times 3 is 27. If you have your calculator, guys, I'll show you how we can put that in the calculator, okay? So we'll do this, and I'll kind of show you. This is 3 times 3 times 3 like that. If you don't understand, or if you do understand that and you want to go straight to 27, you can, okay? But some of us, maybe we haven't seen powers for a while. So that's what we're going to do. That's 27. So we have 3 times 12 minus 27 divided by 9. All right. So we actually still have 3 operations going on. We have multiplication, subtraction, and division. So which one are we going to do first? Multiplication, because multiplication and division are tied, and he's the first one, right? So that's 36 minus 27 divided by 9. And then what are we going to do next? Subtraction or division?
Division.
Division, right? So what is 27 divided by 9? 3. So we end up with 36 minus 3, or 33. Guys, I do not expect, I'm throwing stuff. I don't expect you to do this every single problem you get. I want you to be able to put it in your calculator comfortably and have 33 pop up on there. So if you have your calculator, go ahead and get it out. If you don't have one, start bringing one from renting it downstairs, or because we're going to be probably using it pretty quickly. Your cell phone is a calculator, but it's not programmed to do order of operations, and so it wouldn't work. I just want to show you real quickly how we do this. See where I'm going to turn the light on. I don't know if that will help or not help. That's a little bit better, okay? So as long as you type it exactly how you see it in your calculator, it will work, okay? So I'm going to do 3 times 12 minus, parenthesis, 7 minus 4, parenthesis, and then to raise it to the 3rd power, what we have down here is this caret button, and that caret button on your calculator will raise it to any power that you need it to. Squared is the most common, so notice the squared has its own button, all right? So then we're going to do raise it to the 3rd, and even a scientific calculator will have order of operations, and then divided by 9. It's a lot quicker to do that than all the crazy steps that we did, okay? Number 2, it's kind of the same idea, but notice we have 2 sets of groupings. We have the brackets, but on inside of the brackets we have parentheses. So it's like, oh, we're going to go here first, but inside here, what do we got to do first? That guy, okay? So everything else stays the same. 9 plus 2, bracket, 23 minus 4, and then what's 1 plus 2? 3. And we still have brackets. I have parentheses here. If you wanted to do 4 times 3, you can. Anytime you have 4, like right next to it, this is multiplication. So I don't really need that set of parentheses. You can put 4 times 3 there if you want. So the next thing is we're still going to focus on this grouping method, but are we going to do subtraction or multiplication? Multiplication. So we're going to have 9 plus 2 bracket, 23 minus 12. Is that okay? Because 4 times 3 is 12. Not until you get down to one single number can you get rid of your parentheses or your grouping method. So we still need to do 23 minus 12, which is, what is that, 11? So we have 9 plus 2 bracket 11. And this is what I'm talking about. Now that it's one single number in here, the brackets are not really needed. It's just multiplication. 2 times 11. So you have 9 plus 22, or 31. Okay? How do you put it in your calculator? Do you have to use brackets and squiggly brackets and all that stuff? No. You can put a parenthesis here, a parenthesis there, and then 2 back here. Okay? So I'll show you real quickly. Okay, we'll do 9 plus 2, parenthesis for a bracket, 23 minus 4, parenthesis in that same direction for the parenthesis, 1 plus 2, close off this guy, but then we need one more to close off that guy. And you get 31. Okay, so like I said, you're going to be able to use your calculator throughout the course. Only a couple times I'd be like, oh, let's try to graph it by hand or something like that. So feel free to do that. So these are kind of the ones I wanted to concentrate on more than anything, because even if you have your calculator, you have to know to like simplify the top by itself, simplify the bottom by itself, then divide at the very end, okay? So that fraction bar is a grouping mechanism. Act like that's on top is in parentheses and what's on the bottom is in parentheses. So we can even do that if we want to kind of remind ourselves. Okay, on top, what are we going to do? Let's just focus on the top. Actually, it's only over 3, so we don't really have to focus on the bottom at all, do we? So what are we going to do first? Subtraction, multiplication, or addition? So we'll have 26 minus 12 plus 1 over 3. Is that okay? So I just did this chunk first. 2 times 6 is 12. Then we have addition and subtraction. We don't have to do the addition first, do we? Right? They're tied left to right, so we're actually going to do 26 minus 12 first. What do we get there? Is that 14? And then what's 14 plus 1? 15. And what's 15 divided by 3? 5. Is that all right, guys? So if you wanted to do this in one foul swoop, usually even in my calculus courses, though, I don't have them do it all at once. I said, get your top number, get your bottom number, and then divide it. But if you wanted to do it all at once in your calculator, just make sure you have parentheses around the entire top and the entire bottom. So we just do parentheses, 26 minus 2 times 6 plus 1, parenthesis, divided by 3, parenthesis. And you get 5, okay? So it knows, if you didn't do those parentheses, it would take 1 divided by 3 and get 1/3, and that's going to be a way different answer. All right, we're going to do the same thing here where we're going to kind of think of top and bottom, all right? So when we do this, guys, what's the first thing we're going to do on top? Absolute value, right? So those are those brackets. Basically, it means do the math inside, and whatever number it is, positive or negative, a positive pops out, okay? So what's 7 minus 4? 3, so I'm going to just write that right above. But what's the absolute value of 3? How far away is 3 from 0? 3 units, okay? If that was negative 3, what's the absolute value of negative 3? 3, because negative 3 is 3 units. It's just the idea of distance, okay? So if you're okay with that, I'm going to just go ahead and write this as 1 plus 3, no absolute value, because I already kind of talked about it here, plus 3 squared, over, let's go ahead and do the bottom kind of by itself. What's 8 minus 5? 3. So you can do them, like you're like, you just did subtraction. Subtraction is supposed to be one of the last things you do. You can do the top and bottom separately. So what was the only operation to do on the bottom? The subtraction, okay? Are there any questions about 7 times 4 is 3 and the absolute value of 3 is 3? Is that okay? Let's look at this guy. We have addition, addition, and exponent. What are we going to do? Exponent. The exponent. So what does this exponent mean? It means take 3 times itself twice. 9. What's 3 times 3? We're going to have 9 there. So this is 1 plus 3 plus 9 all over 3. Is that okay so far? And then on the bottom, there's nothing more to do. It's just a single digit 3. And on the top, we have addition. So 1 plus 3 is 4. 4 plus 9 is 13. So you get 13/3. And this is what's crazy as the further you get in math. I feel like you grow up thinking improper fractions are like the worst things ever. Like, don't leave it as an improper fraction, change it to a mixed number, blah, blah, blah. But that's actually the opposite the further you get in math, because it's so much easier to deal with fractions when they're improper. So 13/3 is okay because it's reduced. Nothing goes into 13 and 3, okay? But if you wanted to change it into a mixed number, do you remember how to do it?
Yeah, you would have to do the 3
into the 13. Yep, exactly. So it's basically long division, right? How many times does 3 go into 13? 4 times, with a remainder of 1. Because what's 4 times 3? 12. Or you put it in your calculator and you get 4.3 repeating. Do you remember how do you show 3 repeating? Have you guys seen that bar before? There's a bunch of different ways. I would take all 3 unless I told you a certain one, okay? My math lab will probably specify. They'll say leave it as an improper fraction or write it to decimal rounded to 2 spots or something like that. Are there any questions on the front page? Is absolute value or square root new to anyone? Have you all seen it at some time? Okay, so I have a couple sections over square roots and stuff like that. I want to make sure we feel comfortable. We're going to see absolute. I kind of quickly went over it, but he will show up a variety of times, so I'll try to reiterate what exactly that is. All right, so this is kind of the same idea, but they're like, okay, now that you know order of operations, what if we throw in fractions? What if we throw in variables, right? New stuff. So let's look at this one. Example 5 is 9/5 times 1/3 minus 1/3. What are we going to do first, the multiplication or the subtraction? Multiplication, okay? So this is where, again, I feel like your calculator is going to help you more than anything. Look what we can do in our calculator. what we'll do is we'll type 9/5 in parentheses, so 9 divided by 5 times 1/3, 1 divided by 3. And at first it gives you a decimal, and you're like, Molly, how does that help me? We have fractions. All of a sudden it turns into a decimal. You have a button that changes any decimal to a fraction on your calculator. If you hit math, and then see the very first thing is fraction, it means it'll change it to a fraction. It's actually 3/5, okay? So the answer here, guys, is 3/5 minus 1/3. Does anybody remember how to multiply fractions by hand? It's like you learn it and never use it, right? You can simplify, or you can just go straight across the top, straight across the bottom, then simplify. So if you look at that, what's 9 times 1? 9. What's 5 times 3? 15. So you get 9/15. But what number goes in both 9 and 15? 3. So you divide out a 3 on top and bottom. You remember doing that way back when? Like they teach it and they're like, here's a calculator. Like you never have to do it again by hand. All right, subtraction. This was always the hard part of fractions. Do you remember what you need in order to subtract fractions? A common denominator, right? So again, if you have your calculator, what's great is you can actually just type what we have going on. You can type parentheses 3 divided by 5 minus parentheses 1 divided by 3. Hit enter. They'll give you a weird decimal, but that's okay. We'll just go ahead and hit math, frac, and we know the answer is 4/15. Isn't that great? You didn't have to do any common denominators or anything, right? Let's keep that in mind, but I'll show you how to do it by hand. We know we have a common denominator. What's it? The smallest number that both 5 and 3 go into? 15. And how I do it is I always start with the bigger denominator. And I say, does 3 go into 5? No. And then I double my biggest denominator. 2 times 5 is 10. Does 3 go into 10? Nope. Then I triple my biggest denominator. 3 times 5 is 15. Does 3 go into 15? Yep. So my common denominator is 15. Is that all right? So you ask yourself, what did we do to, hold on. I just never reduced. Okay. So what did we do from 5 to 15? What did we multiply by?
3.
By 3, okay? So what we're going to do is we're going to multiply the top by 3. Again, I'm not going to get too in-depth because we don't ever have to do this by hand. But just think if you had a cake and you had 5 slices and you're like, crap, there's 15 people in the class. You could just go and take each of those 5 slices and cut them into thirds, okay? You tripled the amount of things you had. So if you multiplied 5 by 3, you got to multiply the top by 3 to keep that proportion the same. So this is really 9/15. What did you multiply 3 by to get to 15? 5. So what are you going to multiply the top by? 5. So those two, 9/15 and 5/15, are the exact same ratios, okay? 9/15 is the same thing as 3/5 of the cake. And then 5/15 is the same thing as 1/3 of the cake. But now they have the common denominator, we can do the math with the numerators. What's 9 minus 5? 4. And that's what we knew we were going to get, 4/15. If you're like, oh my, Molly, that's way over my head, that's okay. Don't get scared, because it's one of those things that we don't have to be able to do this by hand. It's nice to know and be able to check, but once you have your calculator, you're going to be able to do all of it on your calculator. All right? The next two, examples 6 and 7, are introducing variables. Have you guys seen variables before? Okay. Variables just mean they can vary. So notice on number 6, you have 20 minus x squared, but they give you a specific x, but does x always have to be 3? No, it could be -2, it could be 18, I don't care. It could be anything, okay? So the first step we have to do is just plug that value of 3 in for x. So you have 20 minus 3, my lead's leaving me, squared, like that. Is that okay? 20 minus, ooh, that's really light. 20 minus 3 squared. Then once you plug it in, you just do your normal order of operations. What are you going to do first, subtraction or the squaring? The exponent, right? So 3 squared just means 3 times 3. What's 3 times 3? 9. So you have 20 minus, I knew that was going to happen, 20 minus 9, or 11. Again, we can throw it in our calculator. 20 minus 3 squared, 11. So it's pretty great. Last one's the same idea, but notice right now we have 5 and it's just shoved right next to y squared. What operation is that when they're shoved right next to each other? Multiplication. So we have 5 times 4 squared. And again, we have two operations. multiplication and the exponent, but we're going to do the exponent first. So what's 4 times 4? 16. That might be something that we're not too sure of, so we'll just throw it in our calculator. 5 times 16 is 80. Is that okay? And those that like today don't have a calculator, if you want to try to use your cell phone for the different chunks of it, feel free. So how would you do this on your cell phone? You could just do 4 times 4 and then multiply that by 5.